So we are interested in finding out when series converge to a finite number and when they do not. There is a notion of something called absolute convergence, which arises because we talk about alternating series. Okay, we say a series is absolutely convergent if the series of its absolute values is also convergent, right? For example, um, we take this particular series here. This is 1 minus 1 over 2 squared plus 1 over 3 squared minus 1 over 4 squared and so on. Now, what is this sequence with its absolute values is going to be 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, so on. This is a P series with P equals 2, right? And this is convergent. Now, if this is convergent, that means, therefore, the sequence is what we call absolutely convergent. This is the alternating harmonic series that we just saw in the previous video. We know that this converges, but if you look at the absolute value, then that becomes that's a P series with P2, with P1, which is divergent. Therefore, this sequence is not absolutely convergent. We have a word for it. It's called conditionally convergent, meaning that it's only convergent if you don't take its absolute values. Now, I'm not going to prove this, but this should be fairly obvious that if a series is absolutely convergent, then it is convergent for sure. Let's look at this example here. Determine whether the series is convergent or divergent. Now, what is this? This is cosine 1 over 1 squared, cosine 2 over 2 squared, cosine 3 over 3 squared, and so on. Now, because the cosine function is positive and negative sometimes, it can have positive and negative values. What we do know is that the absolute value of cosine n over n squared is going to be less than 1 over n squared. Why? Because absolute value of cosine is bounded at 1. Now, what do we know about this series? This series is convergent. If this series is convergent and this is less than a convergent series, right, implies that this is also convergent. Yeah, we had a name for this test, comparison test. But if you think about it logically, if you are less than something finite, then you are also finite. So what we have shown here is that the absolute value of this series is convergent. Therefore, the series without the absolute value is also convergent. Now, if you think about it a little bit, what the absolute value does is it makes everything positive. So if you're adding a bunch of positive things and it's finite, and then you change some of those positive to possibly be negative, it cannot be more than what you had before. So it also has to be finite. That's the end of that.